Okay. An X-intercept. What does the word intercept mean? If you intercept a pass, what does it mean? Forget math class. What does intercept mean? Get in the way of something. Perfect. Excellent. So an X-intercept is the point on the X-axis through which a graphed line passes. Does everybody understand what I am saying? Okay. Now, in this space right here, draw a little Cartesian plane. Just a little one. Okay. And then draw this line. Everybody cool with that? How many X-intercepts does that have? One, because it crosses the X-axis once. No, that's why it's called an X-intercept. Okay? Everybody cool? So I'm going to put me a big old X on the X-intercept. Everybody got it? Now, what are the coordinates of that point? These are coordinates. I need an X and a Y for that point. What are they? That point right there. Pause that. You're guessing it's positive 2, right? And why are you guessing it's positive 2? I'm not saying you're right or wrong. There's no numbers. Excellent. But you know it's positive. Why do you know it's positive? Because it's to the right. Excellent. Good job. But do you know its value? No, you do not know its value. So what do you give it in math class when you do not know its value? A letter. What letter should you give this X-intercept? X. Awesome! Do you know its Y value? 0. Does everybody understand why that is so? Because this point right here is at 0 on the Y-axis. Do you understand? Excellent. Now, I'm going to draw another one. Draw another one of these. Now, draw this line. Now, how many X-intercepts are there? 2. Where are they? I've just got to do my usual $4,000 restart. Oh, awesome. Oh, look at that. That's impressive. Oh, money well spent. If only. 2 X-intercepts. What do you know about their coordinates? One is negative X and coordinates. Negative X, 0, and what's the other one? Positive X, 0. Everybody cool? Okay, now I've shown you 3 different X-intercepts. I've shown you something that has happened thrice in math class. What does that mean will always happen? If it happens thrice, will it always happen? Yes. So what are the coordinates of every single X-intercept? X, 0. Does everybody understand that? Yeah? Okay. So, in green over here, all X intercepts are x comma 0. Everybody with me? Now, did I just give you an equation? Yes. Does that equation have x and y? Yes. Did I just give you coordinates? Are those coordinates x and y? What can I do with that and that? What? What did I do with 6 and 3? Put it in there. So what do I do with x and 0? Put it in there. What will x become? No, x will be x. What will y become? 0. 9 plus 0 is 9, right? Then we would solve it, right? And x would equal 9. So what would I write there? 9. Meaning the x-intercept of that graph is 9 comma 0. Is everybody good? Is that complicated? That's an x, that's an x. That's a y, that's a y. Is that beyond anybody's grasp? Excellent. You guys are very smart young people. What then, since you now know what an x-intercept is, what then is a y-intercept? It's the point on the y-axis through which a graphed line passes. Now you guys are smart kids. We'll do the first one the same way. Where's the y-intercept? Is it here or here? There. What are its coordinates? If the x-intercept is x0, what's the y-intercept? 0y. All y-intercepts are 0 comma y. Is everybody good with that? And I'm going to spend a long time talking about that because for some reason that is a lost piece of knowledge for most of you guys that I have taught math to for many, many years. Is everyone okay with that? And everyone understands that I can go back to here? Yes? Really? Okay, so I'm going to go ahead and I'm going to draw this. Everybody cool? I'm going to put 4 dots on it. All right? There's dot 1. There's dot 2. Of course it did. We're going to start with those 2. All right? Now, when I connect them, I'm given an x and a y-intercept, yes? What is a possible value for this right here, right now? What is the only stuff you know? That it's a positive x and it's a y. What is the only stuff you know up here? It is 0 and it's a positive y. Everybody cool? Everyone is good? Now, if I told you that this had a graph of x plus y equaled 7, could you tell me the x and y intercepts? Why? Because you have everything you need, don't you? If I wanted the x-intercept, what would I do there? You would have x plus 0 equaled 7, right? And x would equal 7. Yes? If you had the y-intercept, what would you have? 0 plus y equaled 7, and y would equal 7. Is everybody good at that? Now, have you actually told me what the x and y intercepts are yet? No, because you have never written it as a coordinate, have you? What is the x-intercept here? 7, 0. And what is the y-intercept? 0, 7. Can everybody do this? The question tells you how to do it. Is everybody good? Okay. Now, that is kind of grade 9. Let's look at this from a grade 10's perspective. What is different about the equation that I have now? It's in function notation, right? What do we have to remember about f of x? What is that really? Input, output, dependent, independent, what? The x in the bracket will go into the equation, yes? So the f of x must be my output or my y values. Agreed? Everyone agree? Okay. I want the x and y intercepts for that line. What do I know about x-intercepts? They are all what? x0. Correct? So, the x is still an x, isn't it? But the y is 0. I have f of x equals 2x plus 3. Do I know an x value right now? No, because my x value is an x. Do I know an output value? 0, because my output is y. So what can I sub into this equation? Can I put something in for x, or can I put something in for f of x? For f of x. And what can I put in for f of x? 0. So I have 0 equals 2x plus 3, don't I? Do I have an x yet? Do I know how to do algebra? How do I solve that? Minus 3 from both sides. Negative 3 equals 2x. Now what? Divide by what? 2. So negative 3 halves equals x. Is everybody okay with that? Everybody remembers their grade 6 algebra? Okay. So now, if that equals x, what is my x-intercept? Negative 3 halves. And what y value? 0. Everybody got it? Okay. Now, I also need a y-intercept. What is every y-intercept? 0, comma, y. Correct? My y value is y, so where does it go? For f of x or for x? F of x. So y equals 2, what's x now? What's x? 0. 2 times 0 plus 3. Y equals 3. So what is my y-intercept? Equals 0, comma 3. Now I'm going to graph it. Okay? Now, do I have 2 points? I do, but one of them's a fraction, correct? So how do I deal with that? This is what I do. Instead of this being 1, I make this 1. Now I can do halves, can't I? Does everybody see what I did there? I'll zoom in a bunch so you can see. You want to make this 1, don't you? But we need halves. So if I make this 1, what does that make this? 0.5. What does that make this? 1.5. What does that make this? 2. Everybody with me? And my first x-intercept is at negative 3 halves, 0. Correct? So where is negative 3 halves on the x? To the left, how many squares? No, 3 halves. That's 1.5, Sammy. So how many squares? Boys, it's not 3.5. It's 3 halves. I know it's 3, Mark, and I know you know, but I'm wondering why people are saying 7. Each square is worth a half. How many halves do I need to go? I know you were. 3 halves. 1, 2, 3. There's my x-intercept. Does everybody understand why it's that and not 7 squares over, which would be negative 3.5? You're right if it was 3.5, but this isn't 3.5. This is 3 halves. Everybody good? Each box is 0.5 because I needed halves. Now, if each box is 0.5 on the x-axis, then each box should be 0.5 on the y-axis too, right? And what's my y-intercept? 0, 3. So how far up do I need to go? 6. Because each square is worth a half. So there's 1. I'll do this one in red. There's 1. There's 2. And there's 3. There's my x-intercept, or y-intercept. Is everybody okay with that? Now, can I connect the line? Is this discrete or continuous data? Continuous. Why? Because I can put any number in for x, multiply it by 2, and add 3. Okay? So this line would look like this. Does everybody understand? The hardest thing about that is figuring out your scale, right? Could I have done it another way? I'm going to erase this. Do not write what I'm about to write. Let's pretend you do not understand fractions. So 1, 2, 3. There's 3, 0, 3, right? So how do you do the negative 3 halves? Well, that makes that 1, so that's 2, so you'd have to put your dot at 1.5. Everybody okay with that? That makes it hard to graph. That's why I used fractions. Okay? Everybody good? All right. Let's look at the next one. Domain and range of f of x, just a quick reminder. What's the domain? Is domains x's or y's? Domains are x's. So, can I put any number in for x? Anything. Yes. So it's all real numbers, isn't it? All real numbers. And there's a lot of different ways we can write that. I don't really care. Okay, you can write it like this. X with the funny little e and then a big R. You can write it negative infinity, round bracket, positive infinity, round bracket. I don't care. Just understand you can put everything in. And what's the range? If I have negative infinity and I multiply it by 2 and add 3, is it still going to be negative infinity? Yes. So y's are the same thing. All reals. Y is a set of real numbers. negative infinity, positive infinity. Is everybody good? Yes? Okay, that's essentially the whole lesson. If you can figure that out, you can do everything. So, what do we have here? Turn the page over. What do you got? What is this g of x really in graph speak? Y. So this is y equals 1/2 x minus 2. Correct? What do you know about every single x-intercept? You have x, 0, and you have 0y. Correct? Those are our intercepts. Agreed? Okay. So how do I do this first one? What goes in for x? It's a trick. I want you to screw this up. X, because you don't know what x is, so you have to leave it as an x. What goes in for y? Y. Because these are coordinates, x and y, aren't they? So y gets 0. 1/2 x minus 2. How do you solve that for x? Add 2 to both sides. 2 equals 1/2 x. What does x equal? How do you get rid of a denominator? Times by 2, because that's what the denominator is. So I multiply both sides by 2. And x equals what? 4. So what is the x-intercept? 4, 0. Do I want to put that on the graph yet? No, because I don't know. Y might be a fraction, right? I might need to mess with my scale. Come over to this one. What's happening over here? Do I know x? 0. So y equals 1/2 x. Oops, not x, because x is 0 minus 2. So y equals what? 0 minus 2. Negative 2. So what is the y-intercept? 0, negative 2. Everybody cool? Any fractions? Nope. So I can go ahead and just put it on my graph, can't I? 1, 2, 3, 4, 0. Down 2, negative 2. Can I connect the line? Yes. Why? Because it's continuous. Because every number can be cut in half and add 2 subtracted from it. Is everybody good? Now, I want you to notice something. Because remember, if it happens twice in math, it's going to always happen, right? Look at the y-intercept here. What was it? 3. Everybody see that? Look at your next one. What was the y-intercept? Negative 2. What did you see there? Negative 2. Everybody see those two things? Okay. Keep that in your head. Y equals mx plus blank. Everybody see that? Does that look anything like the two equations you just saw? You do have the b? Damn it. Okay. That's all right. You're not supposed to have the b, but that's cool. This looks like the two equations you just saw, yes? Describe this equation to me in words. Pretend this wasn't written here. Describe this to me. What is something you would say about this equation? You guys all have words. You know how to talk. Pardon me? No, you're absolutely right. That is something about this equation. Yes. Keep talking. This is like a brainstorm. Anything you can tell me about this. What would you say about that? Describe that mathematical thing to me. Yes, it's a y. What else would you describe about that y? Pardon me? You don't know what it is. Excellent. What else can you say about that y? Y equals. Y is isolated. Is everybody cool with that? Okay. So, y is isolated. That's one thing you could say about this form, yes? Agreed? Now, what else do you know about this form? Remember, you guys are the ones that told me this looks exactly like these two equations we just did. What did you notice about that and that? That they gave me what? B two. When y is isolated, B is my y-intercept. That is something that you already proved with the last two questions. Do you all understand? Okay, so if I give you this, 2x plus y equals 4, can you tell me the y-intercept right now without doing any of this substitution that we just spent the rest of the class doing? What would you do? You would move the 4. I'm going to highlight something. Y isn't isolated yet, is it? Can I isolate y? What would isolate y? Divide. I want y to be alone. Think back to grade 6 when Mrs. Bad Crumble was teaching you algebra. What do you have to do to get y alone? What's near y right now? 4 is not near y. There's an equals in the middle of it. 2x. How do I get rid of a positive 2x? You subtract 2x. Where else? From the other side. Now, can I do that? No, they're not like terms. So I end up with negative 2x plus 4, don't I? Is y isolated now? Do I now automatically know the y-intercept? What is it? 4. Everybody cool with that? Excellent. Okay, now the next thing we are going to talk about is that m right there. M is slope. Slope is, you guys have already seen it as rate of change. And it makes a difference. I will remind you of why. Remember when we graphed the bear? As the bear got faster, the slope changed, yes? Right? So how do I find a slope? It's how much one variable changes compared to the other variable. Now on a graph, without any numbers, what are the two variables we have? On a graph, with no numbers, what are the two variables that we have? We have x and we have y, correct? And if there's going to be a slope, there has to be a change, doesn't there? So I'm going to start at 0, right there, 0, 0. If I'm going to have a slope, and I go this way, do I have a slope? It's not a trick question. Yes or no? Is there a slope? No, of course not. Because the y value didn't change, did it? So I have no slope because there wasn't a change in my y value. What if I go this way? Again, I can't have a slope there because I have no x value changing, yes? What is the only way to get a slope? I have to change them both, don't I? I have to go over 1 and up 3, and then I would get a slope, wouldn't I? Does everybody see that? Yeah? Okay. So slope is the rate of change, and we're going to talk about them all right here. Label this guy A and label this guy B. Pretend that's on a graph. Okay? We're going to draw the graph right here. Is everybody with me? Everybody's with me? Okay. Here's Mr. Myers. I am going to walk from A to B. As I walk from A to B, what is happening on the x-axis? It is changing. In what direction, Abresia? Positively. So as I walk up here, my x is going to be going positive, isn't it? Everyone understand? Agreed? And as I walk up here, what is happening to my y value? It is changing as well. In what direction? Positively. So my y is going to change positively, isn't it? So as I walk... Oh, I left my head. Oh, no! As I walk up to there... Oh, and I left my right leg! What a horror! It's the... That's blood. Okay, stop it, Myers. You don't have to be that way. But everybody understands that, yes? From A to B, I went up in a positive direction, and I went to the right in a positive direction. Everybody cool with that? Okay. Which means I get a positive slope, because I changed positively in both directions. Does everyone understand that? Now, what if I reverse? Now I'm up here. Now I'm going B to A. What happens in the x direction? It goes negative. And what happens in the y direction? It goes negative. I have two negatives. What happens when we do anything with two negatives? It stays positive. Is everybody with me? So that is a positive, what we call a positive slope. Because both variables are changing in the same direction. Everybody cool? All right. So the next one, you guys should already be able to figure it out. There's B, there's A. I'm going B to A. So as I go B to A, what happens to my x value? It is going in a positive direction. What happens to my y value? It is a negative direction. Everybody with me? And if I reverse that and I go A to B, what happens to my x? My x is negative. What happens to my y? My y is positive. So this is what we call a negative slope. Because the signs are changed, the directions are opposite of each other. Everybody cool there? Okay, what about this one? B to A. What's happening? There's only one changing, yeah? Which one's changing? It's either negative y or positive y, yes? Is x changing at all? So, If I was doing a displacement graph, is that possible? No, why not? What's not changing? X. And what is X on a displacement graph, Sammy? What is X on that graph of the bear we did? What'd you put there? Time. Can time stop? No. So is this a possible slope? No. So this is what we call an infinite slope. Because it can't exist in reality. Understand? Now what about this one? A to B. X changes. Is that possible? Time can't go on without moving? Is that possible? So is that change that can happen? Yes, that's what we call a zero slope. Does everybody understand? Everybody's cool? So, excellent. You already know slope equals m, right? From what I just told you at the beginning. But it also equals the change. I'm going to write that out. I'm not going to use the change in y divided by the change in x, which when you take physics class will be written this way. Delta y over delta x, and it will also be written as rise over run. And it will also be written a third way that I am going to talk about in a minute. But that's where that's all I want to talk about now. Is everybody cool? Okay. Turn the page over. Go to page 3. And this says to graph and label it. Okay? So how many lines will have to go on this graph? 4. Yes? A, B, C, and D. Is this already set up to graph for us? Yes. Why? Is y isolated? Isn't this... Oh, I should do it in blue. Y equals 2x minus 4. It is, isn't it? What's the y-intercept then? -4. So I go to -4, 1, 2, 3, 4, and I put a dot. Is everybody cool with that? Does everybody understand what I just did there? I went to my y-intercept of -4 because y was by itself, so I know that b is -4. Everybody cool? What's my slope? Slope is m, right? What value in this equation is m? M equals 2. Now I told you slope is always rise over run, isn't it? What is 2 really over? What's the number that if I was making 2 a fraction, what would be the denominator? 1. Does that give me a rise and a run? So how do I get from this point to rise +1? Is that up or down? Up. How far? 1. It's rise over run. So up, 1, 2, and then what? To the right 1, because they're both positive. Does everyone agree? Does everyone see it? So I'm going to go up, 1, 2, and over 1. Now, could I do that again? Yeah, because it's going to make a line. Up 1, 2, over 1. Up 1, 2, over 1. Can I go the other way? Yeah, but they both have to be negative, don't they? So I could go down 2 and -1. Down 2 and -1. Does everybody get it? And then I make my blue line. Everybody cool? Okay. So who's going to tell me where to put the first dot for the red line, which is B? It's at positive 1 on which axis, Caitlin? Y or X? Y. That's the y-intercept. Now, what's my slope? There's no number there. So what's the number when there's no number? 1. Negative 1. So I got to go where? Down 1? Down 1 and to the left would be both negatives, which would give me a positive slope. Right, down and to the right. And how far can that go on? Can I do it again? Can I do it again? Can I do it again? Can I do it the other way? Can I go up 1 and left 1? Yes. And there's my other line. Is everybody cool with that? Okay. Uh-oh. What's happening with the green line? Where's my first dot going? No. The green line is C. Where's my first dot going? Please notice we started at negative 4, we started at positive 1, positive 5. 1, 2, 3, 4, 5. What's my slope? Negative 1 over 3, right? Slope is always rise over run. So what's my rise of negative 1? Is that up or down? Down 1. And then right or left 3? Right. Could I also go up 1 and left 3? Oh, did I? Okay. Sorry. 1, 2, 3, 4, 5. I did indeed. Down 1 over 3 and up 1 over 3. And then I would draw that line. Is everybody cool? All right. Now finally. Yes. I'm sorry, what? Because if I go down 1, I would need to have a positive run. If I go up 1, I would need to have a negative run to keep my slope negative. And what about this one? There is no y-intercept there, is there? So what number is it? There's no y-intercept written there. Where on the graph is nothing? 0. So that must be my y-intercept. 0, right in the middle. What's my slope? Positive 1, right? Right? So I would go up 1 over 1, up 1 over 1, down 1, left 1, down 1, left 1. And I make that line. Now, your homework is number 2 and that from your textbook, 384 and 362. Remember, X's and Y's. That's all that matters. You get them from the graph, or you can put them in the equation. Either way. Not today, because the bell's about to ring.